All right, on to applications of logarithmic functions and exponential functions. To start, let's talk about some common formulas used with logarithmic applications. First is interest. What is interest? As a consumer and a borrower, we basically either pay or earn interest. Interest is money paid for the use of the borrowed money. Okay, you guys are probably used to what we call simple interest. This is interest calculated over the life of a deposit or a loan. The formula for simple interest is just I equals PRT, where I is the interest earned, right? P is the principal or the amount deposited. R is the rate, and anytime we deal with rate, right, we need to convert the percent to a decimal, and then you have time, and that's generally in years. Okay, remember, principal is the amount borrowed or deposited. Okay, next is compound interest. This is somewhat more common in the real world versus simple interest. And compound interest is interest that is calculated more than once over the life of the loan. Compound interest is getting interest on the principal and on previously earned interest. And through an example, I'll try and explain what this is. But the formula for compound interest is A equals P, right, times 1 plus the rate over N raised to the NT, where A is the amount in the account after T years. P is the principal or the amount deposited. Rate is the percent, but we want to change the percent to a decimal. N is the number of times per year compounding, and T is the time in years. Okay. Now, when we talk about how many, N, the number of times per year, if we say semi-annually, that means every 6 months, or N would be 2 because that would be 2 times per year. Quarterly is 4 times a year or every 3 months, so we would say N is 4. Monthly is every 12 months, or N would be 12. So this number is how many times per year are you compounding? And daily would be 365 times per year, so N would be 365. But there's another type of compounding, and it's called continuous compounding. And this is when money is compounded faster than daily, faster than hourly, faster than every second. It is being compounded continuously. And the formula for that is A equals principal times E to the RT, where, again, A is the amount in the account after T years, P is the principal or initial amount, R is the interest rate is a decimal, T is time in year, but E is that number E we talked about in earlier lessons. Okay, so let's look at all of these in an example. We don't have enough time to go over every single example. So sometimes you have to use the answer keys to work backwards, right? And I'll answer any and all questions before the exam. So example 1, a credit union pays interest rate of 8% per year compounded quarterly on a certain savings plan. If $1,000 is deposited in such a plan and the interest rate is left to accumulate, how much is in the account after 1 year? Now, if it says compounded quarterly, so let's talk about using that compound interest formula, where we said A equals P times 1 plus the rate divided by N times, or all raised to the NT power. Okay, now with this, right, we know that the initial amount deposited was $1,000 times 1 plus our rate was 8%. 8% is a decimal, is 0.08. all divided by how many times am I compounding each year? If it is quarterly, when it says quarterly, we know n is equal to 4. So that's divided by 4. Then we're going to do raised to the 4 times how many years? 1. Now, if I go to my calculator and I plug this in, right? So I get 1,000, open parentheses, 1 plus, I'm going to do 0.08 over 4. And then I'm going to take that and raise it all to the 4th power. And when I hit enter, that tells me the amount in the account after would be $1,082.43. All right. Now, here's the thing. What are they basically doing here when they're calculating this? And there's something to be said to understand about what this compounding is. So if we use simple interest to figure this out, we know simple interest is I equals PRT. So in this case, the first 3 months, the interest earned in that time period would be 1,000 times 0.08. But remember, the first 3 months is, if I look at it, a quarter of a year is equal to 0.25 years. So we're going to say your time, because time in simple interest is in years. Well, 3 months is a quarter of a year, so we're going to do that. When you calculate this interest, you get $20. So now your new principal, your new P, is going to be the $1,000 plus $20, which now you have $1,020. Well, now the next 3 months. Now in the next 3 months, the interest earned is going to be on this new principal, which is now 1,020 times 0.08 times another quarter of a year. And now the interest earned in this period would be $20.40. So my new principal would now be the 1,020 plus $20.40, which gives you $1,040.40. Now the next 3 months, that would be I equals, right, 1,040.40 times 0.08 times 0.25. And when I calculate this interest, now I'm earning $21.22. So my new principal would be, end up being, oh sorry, this is $20.81. And my new principal then would end up being $1,061.21. So now my final 3 months, when I calculate the interest, and I'm just going to write it down, it would be $21.22. So my final principal after the end of the year would be $1,082.43. That's, sorry about the dog there. So when I look at this, right, this compound interest formula is doing all of these steps in one formula. Okay, so let's look at example 2. On January 2nd, 2007, $2,000 is placed in an IRA account that will pay interest of 7%, compounded continuously. Now that it's compounded continuously, right, we know we're going to use P times E to the RT. So it says, what will the IRA be worth on January 1st, 2027? Well, the amount after, what is our initial deposit? $2,000, right? Times E, what is our rate? If it's 7%, that's 0.07 times, how many years is it from 2007 to 2027? That would be 20 years. And if you plug this in the calculator, you get 2,000 times E to the 0.07 times 20. And it shows that you would have $8,110.40. This is why you should save all your money and invest it now. All right, so basically for sitting on your couch doing nothing, your account balance went from $2,000 to $8,110.40. Next, Jake needs $2,000 for a down payment on a car. He currently has $800 invested in an account earning 6% compounded quarterly. And how many years will he have his down payment? Well, here's the thing. Right now, the amount invested is $800, right? He needs $2,000. We know the rate. We're looking for the number of years. So if I look at this, how much do I need in the end? If I look at it as compounded quarterly, I'm doing P times 1 plus the rate over N times or raised to the NT power. So right away, I know the rate is 0.06. I know N is 4. I know N is 4. The amount I need is 2,000. And the amount I have is 800. So what I have to do is plug everything in here. So I'm going to say 800 times 1 plus 0.06 divided by 4, all to the 4t power. When I calculate this, what do I need that to equal? The $2,000. So now how do I solve this? Well, I'm solving for t, so the first thing I'm going to do is divide both sides by that 800. So now, if I simplify this inside the parentheses, I'm going to say, let me see if I can get this here, 1 plus alpha y equals 0.06 over 4 gives me this decimal, right? So 1.015. 2, the 4t equals, when you do 2,000 divided by 800, you get 2.5. Now, a lot of times in the calculator, once I get that value of 1.015, if you use this feature, if you hit the stow button and then you use X, anytime you hit X now, it will store that value and plug it in. You don't have to use that because it's a decent decimal. But now what do? The next part is I have to get this 4t down. How do I do that? I take the log of both sides. So now I can bring this 4t out in front. 4t times the log of 1.015 equals the log of 2.5. Next, I'm going to get 4t by itself by dividing by the log of 1.015 divided by log of 1.015. So 4t equals, if I go log of 2.5 divided by the log of 1.015, and I hit enter, I get 4t equals 61.5. And now I can divide by 4, and the amount of time would end up being, if I divide that by 4, it would take him 15.4 years. I'll tell you right now, I hope his car now is in good shape because that's a long time. All right. Number 4, cars tend to depreciate about 6% per year. If the current value of the car is $26,000, what will the car be worth in 4 years? Well, the formula I'm going to use here is the initial amount times 1 minus the rate, all to the t power. So in this case, the amount, the value of the car after t years is going to be 26,000 times 1 minus, how much is it going down per year? 0.06 to the 4th power. And if you go ahead and plug this in your calculator, 26,000 times that, so 26,000 times 1 minus 0.06, all raised to the 4th power. If I hit enter, I get $20,299.47. Okay. Number 5, there are 600 people at a concert on a 100-degree day. Due to the heat, the number of people decreases continuously at a rate of 8% per minute. How many people are left after 30 minutes? Because it says continuously, we know we're going to use A equals P times E to the R times T. So, how many people are initially at the concert? 600 times E. Now our rate, since it's decreasing, our rate is negative 8% or negative 0.08. So this is going to be raised to the negative 0.08 times how many minutes? 30. And when I plug that in the calculator, I'm going to go 600 times second E to the negative 0.08 times 30, and ends up being there would be about 54 people left in the concert. All right. Now this last problem, the half-life problem. With half-life, anytime you have a half-life problem, you're going to use A equals P times E to the RT. So when we look at this here, right? Now it says the half-life of radium is 1,690 years. If 10 grams are present now, how much will be present in 50 years? Now, here's the thing. What is missing from here, right? The missing part of the formula is actually going to be the rate. We don't know the rate, right? Because if you think about it, if the half-life is 1,690 years, that tells us if there are 10 grams now, after 1,690 years, how many grams are going to be left? 5. So the way I like to look at it is when I plug everything in here, the amount after 1,690 years is going to be 5 equals how much, what is our initial amount? This is the amount after the 1,690 years. Well, if it's half-life, what's half of 10? 5. What did I start with? 10 times E to the, do I know the rate? No. But how many years, when I go to fill in time, how many years did it take for these 10 grams to go down to 5? It took 1,690 years. Well, I only have one variable left to solve for in this equation, and what is that? Right? That is R. So before I can figure out how many grams are present after 50 years, I have to go and find the rate. So the first thing I do to find that is I get e to the r 1690 r by itself by dividing by 10. And if you think about it, it will always end up this way. I'm going to get 1/2, right? Or I'm just going to make it easy and say 0.5 because that's equivalent to 1/2 equals e to the 1690r. Well, how do I get this down, right? So if I have e to the 1690r equals 0.5, to get this down, what we're going to do is, what's the inverse operation of e to the 1690r? Well, if I take the natural log of this side, and I take the natural log of this basically wipes each other out and leaves me with 1690r equals the natural log of 0.5. Well, what do I do now? I divide by 1690, and the rate ends up being, I go to my calculator, scoot it over, and I'm going to say the natural log of 0.5, right? And then I'm going to divide that by 1690. Now, if you look, you get this weird number, but I'm going to kind of take this number and round it. And I'm going to say it's about negative 4.1, and then it's e to the negative 4. That is scientific notation as 10 to the negative 4. And if I look here, if you remember scientific notation, if it's to the negative times, if it's e to negative 4, I'm moving that decimal place 4 units to the left. So 1, 2, 3, 4. Fill these missing units in with zeros, and the rate ends up being negative 0.000, and I'm just going to use 4. Now that I have my rate, and remember that the rate already is a decimal, now I can go back here and say the amount, right, after 50 years now is equal to, what did I start with? 10 times e to the, now I'm using that rate, negative 0.0004 times how many years? 50. And if I plug that in the calculator, I get 10 second e to the negative 0.0004 times 50, and right away I get, there would be 9.8 grams left after 50 years. So again, when you're working on a homework, you kind of just have to process these. We can't go over every type of example. All right, so sometimes just working backwards from the answer key, all right, noticing where everything's placed will definitely help out. If you have any questions, please let me know.